Flexibility also, it allows intelligent traffic load sharing, so you have to be flexibility is also a principle of borderless network. So the important part of this conversation here is only about around the hierarchical design. So the three tiers of the hierarchical network design are the access, distribution, and the core layer, like I said before. So, but you can also combine the distribution layer and the core layer together. You call it one layer, called it the collapse core. That is, if you are a poor guy, you don't have enough money to put your network in these three hierarchical designs. Okay. So the access layer provides network access to the users. That is the switch level. And then when you go to the distribution layer is where you have your routers, your internal routers, the routers that only deal with your internal affairs. And then if you go to the core layer, is the routers that are as your backbone routers. They're the routers that sit between your network and the ISP's network. So that is the distribution. That's how the tiers are put in. So the distribution layer has a lot of job. It does aggregating layer 2 broadcast domains. Aggregation here is summarized, and it also does summarization of layer 3 routing boundaries, provide intelligent switching, routing, and all that. So that's why it is one that deals with your internal routing and internal network management. So all that is done at the distribution layer. So if you are somebody that cannot do this division, you can combine your distribution and the core layer. So whereas you have the same routers that you have, your same router is doing the distribution services, the same router is doing the core service also, because you don't have enough money. So that is it. The hierarchical switch LAN allows more flexible traffic management and also additional features such as quality of service, additional security, the support for wireless networking and connectivity, and also support for new technologies. So that's the role of a switch network. So we'll have to learn a lot of these things in our next chapter. So the form factors we said is how switches come in different forms. So we have fixed switches, we have modular switches, and we have stackable switches that you will combine together as one, multiple switches being string in the one functionality. And modular are those that you can be able to add modules and remove. So most of the time in Africa we see the fixed configuration switches. They come in like that. You cannot add anything, you cannot reduce anything from them. Alright, so switching as a general concept in networking, what switches do is that they only serve as a platform to forward frames. Okay, so the switch makes decisions based on two criteria. That is, one, the ingress port, that is the port that the frame is coming in, and the destination address, which is the MAC address of the destination device. So a LAN switch maintains a table that it uses. Like I explained about this, I said switches have what we call the MAC address table that they will maintain, and then they know which port the frame comes in and what destination MAC address was used on that particular port. So it takes control and then it takes charge of that and make sure it keeps record of those things. This is the difference between the hub and the switch. Hub does not have this kind of thing, but switch does. It has a content addressable memory, or some call it the MAC address table, where it can store devices that first send packet through a particular port, a frame through a particular port. So if a message enters to a port, for instance port 1 with a destination address of EA, for example, then the switch forwards the traffic out port 4. Okay, and because the destination MAC address is EA. Okay, so EA is connected to port 4. Alright, so that is what you are. So layer 2 Ethernet switches forward frame based on the destination MAC address and the source port number. Alright, so not IP address. The switch forwarding methods are two in number. We have the store and forward method, and we have the cut through. I explained these ones previously, so it's just a repetition. The cut through is a method that the switch would forward the entire frame without having to check whether the frame is valid or not. And then also for the store and forward is the slowest but the most efficient one, the most reliable frame forwarding method, that it will store the entire frame, run the frame check sequence, or run the cycle redundancy check to see if the frame, all the parts of the frame is active, everything is good. Then it will locate the destination and then forward the frame to that destination. That is the store and forward. Very good and reliable. But store and the cut through is not reliable. It's a very fast, unreliable one. It just needs to know where the packet is going, and then upload and then download some 50-second or from some seconds of data, and then it forward. Just like when you're watching your footballs online. When you're watching football online and somebody listening through radio will say, oh, goal, and then you will be like, where is the goal yet? Because there was some buffering that was done before the actual video comes in. So that is one thing that you need to understand. So features of the store and forward is that the switch will entirely download the entire frame, and then it will use FCS, that is the frame check sequence, and CRC to check if the frame is valid, and then it will automatically buffer the ingress port buffering process. That will provide flexibility for support any mix of Ethernet speeds, and then you have different speeds. So store and forward is a Cisco primary LAN switching method, so if you want also you can change. So we have other method that is a cut through. Cut through have different variations. We have the rapid frame forwarding is a cut through. It's a type of cut through where the switch make forwarding decisions as soon as it has looked up the destination MAC address. So with these frames with errors are forwarded. The other best one is called the fragment frame. It's a type of cut through that would modify. It's a modified form of cut through switching that would make sure that it waits for at least the first 64 bytes of data to come first, and then it will pass the forward, start forwarding the frame. So it provides better error checking than cut through, with particularly no increase in latency. So you may be asked in an exam which of them provide the lowest latency level of latency. It is a fragment free. So we have collision domain. Collision domain is an area of a network that is affected by a single collision, and we have to understand that hubs, the entire hub is a collision domain, and every port of a switch is a collision domain of its own. So Ethernet switch port will auto negotiate for full, and then we have duplex, that is a speed and duplex. So let's look at here. I'm going to make some quick explanation on this one. So let me just get rid of this one, and alright, I'm going to have to wipe this out so that we have something to discuss out here. Alright guys, so let's go back. Let's talk about a hub. Okay, now this is my hub. This is my entire hub. So every port on this hub, every port, including the hub itself, every port here connecting to this hub, the entire hub right now is one collision domain and one broadcast domain. If there is a problem, there is a collision on this port of the hub, all these other ports that are left here are also going to face the same problem. So that is why an area, they said the area of the network that is affected by a single collision, the entire of a hub is one collision domain, meaning if one port of a hub goes down or has a collision, the entire hub has a collision. Now let's talk about a